Imagine standing on a planet orbiting a colossal black hole, where no sun rises and no familiar dawn ever comes near.
Above you, a brilliant disk of fire spins around an invisible core.
You might wonder, could a planet really orbit something that devours light itself?
Surprisingly, gravity here follows the same laws as it does around a star, only stronger and...
Instead of sunlight, this world is illuminated by destruction.
Near a black hole, light doesn't travel straight. It twists, folds, and circles back upon itself, weaving an...
If you looked up, you'd see the sky reflecting itself, stars above and below, bending into a cosmic mirror.
Every beam of light tells a story of survival. Escaping
Time itself slows here. A few hours on this planet could mean years elsewhere in the universe. Imagine leaving this world and returning to find centuries have passed, your loved ones long gone. Even without a sun, this planet still has its own rhythm of light and shadow, its surface glowing amber, then its day comes from the swirling plasma around the black hole, a storm of eternal fire and motion, casting... And when the world turns away, night falls, not in silence, but with faint auroras dancing across the sky.
Each flicker you see is matter dying, its last breath released in a burst of light before vanishing forever.
From destruction comes creation. This planet endures by feeding on the dying glow of the cosmos.
Seen from afar, it's a fragile marble.
A black hole fills its sky, a dark sphere rimmed with fire, bending the constellations into ghostly rings. Somewhere in our galaxy, such a world might exist, silent, ancient, and bathed in borrowed light.
The universe doesn't simply destroy, it transforms.
Imagine standing on a world so close to a black hole that time itself begins to slow down.
Here, seconds stretch into minutes, and hours could equal years on Earth.
Have you ever wondered what it would feel like to live where time itself changes its pace? On this planet, time doesn't flow evenly. It bends and stretches under the pull of gravity.
Einstein taught us that gravity doesn't just pull on matter, it pulls on space and time themselves.
Picture the universe as a giant sheet. The heavier the object, the deeper the dent it makes.
A supermassive black hole tears an enormous pit into this cosmic fabric, trapping even time itself.
As you approach the event horizon, your time slows compared to anyone watching from afar.
To someone observing from Earth, you'd seem to move slower and slower, until you appear frozen in time.
But to you, everything feels normal. Your heartbeat steady, your thoughts unchanged. It's one of nature's greatest paradoxes, where time itself loses meaning near the edge of eternity.
On Earth, this effect is tiny, but it's real. GPS satellites must adjust for time's slow drift in orbit.
Without that correction, your GPS would drift miles off course in just a few hours.
Near a black hole, those tiny differences explode into something enormous, a natural time machine. No sci-fi tunnels, no glowing doors. Just the raw physics of the universe bending its own rules. If you could survive near that edge, you might watch centuries of the universe pass in minutes.
But it comes with a terrible cost. Cross that horizon, and nothing can ever return.
Black holes remind us that time isn't a number on a clock. It's part of the universe itself.
They are cosmic mirrors, showing how fragile and flexible reality can truly be.
So next time you look up at the night sky, remember, somewhere out there, a single second might last forever.
Near a black hole, even time must bow to gravity's power.
Because black holes don't just consume matter.
Imagine standing on a planet with no sun, no dawn, no sunset, yet the sky glows as if alive.
Here, light doesn't come from a star, but from the heart of darkness itself.
Matter spirals inward at nearly the speed of light, heating to millions of degrees.
Every atom, every particle collides and burns, creating a storm of radiant fire.
This chaotic inferno, the Accretion Disc, is the only source of light for this strange world.
Gravity bends light here, wrapping it around the black hole like ribbons of molten glass.
Look up, and you'd see light coming from every direction, bending, folding, and reflecting itself.
Shadows stretch in impossible directions, cast not by one sun, but by 1,000 reflections.
Here, day and a night are illusions. The planet's orbit decides when light lives or dies.
When it faces the disk, the world blazes with warmth and color.
Scientists call this phenomenon gravitational lensing, where gravity bends the path of light itself.
It's like set inside a cosmic hall of mirrors.
And every sunset here isn't a sun disappearing, but a black hole glowing from within. The sun doesn't set. Here, the black hole shines in the dark.
It's a paradox only the universe could create. Darkness that gives birth to light. An accretion disk can outshine entire galaxies, powered only by destruction itself. Matter dies, energy is released, and for a moment, darkness becomes the brightest thing in the cosmos. And yet, even that brilliance fades when the black hole finishes its feast.
Imagine living there, beneath that eternal glow.
Every second would remind you that beauty and destruction are two sides of the same truth.
When you gaze into the dark, you realize something profound. The black hole. Imagine drifting near a supermassive black hole, a place where light vanishes and time bends. You might think nothing could survive here, but in space, danger often hides unexpected life.
What if the most hostile region of the universe could also be the most energetic?
Around a black hole, gas and dust collide, forming a plasma storm called an accretion disk.
This disk shines brighter than billions of stars, flooding nearby worlds with heat and light.
If a planet orbits at the right distance, not too close, not too far, it could absorb just enough warmth. Scientists call this the habitable zone, a cosmic Goldilocks region where conditions might allow liquid water.
Here, the black hole replaces the sun, and destruction itself becomes a source of life.
If the planet has a thick atmosphere or strong magnetic field, it could protect life from deadly radiation.
Life might adapt to that energy, thriving in warmth born from destruction, not sunlight.
On Earth, we've found microbes living in acid lakes, under Antarctic ice, even near volcanic vents.
If life can exist there, why not in the twilight of a black hole's world?
Some astronomers believe that, in the far future, these planets might become life's final refuge.
Long after the stars fade, black holes will still shine, feeding on the remnants of the cosmos.
Even when all other energy sources vanish, these worlds could still be warmed by the glow of collapse. It's a strange idea that life might one day owe its survival to the very thing that destroys. The black hole, symbol of death, becomes a cradle of endurance, a reminder that creation and destruction are twins. Perhaps somewhere, deep in that eternal night, life already watches the dance of light around the abyss.
Because in the universe, even destruction can become creation.
Imagine living on a planet orbiting a black hole, where seasons are measured not by sunlight, but by survival.
As the planet moves in its long, stretched orbit, it swings from fire to ice, from chaos to silence. When it draws close, the sky ignites, storms rage, lightning cracks, and the surface begins to melt.
Imagine oceans boiling, winds faster than sound, and thunder shaking mountains of glass. This is the black hole's summer, a season born from gravity's fury.
But as the planet drifts away, the glow fades, and a cold silence spreads across its frozen seas.
Far from the black hole, light weakens, temperatures plunge, and darkness becomes absolute. Then, as night falls, something extraordinary happens. The sky comes alive with black auroras.
These aren't like Earth's auroras. They're born from deadly radiation, twisted by magnetic storms. Each flash marks a cosmic storm, charged particles racing from the black hole at near light speed.
From the surface, the sky would shimmer as if breathing.
Scientists call this the aurora of doom, both mesmerizing and deadly to anything unprotected.
Each sees it here rewrites the planet's story. Fire. Life, if it exists, must hide beneath the surface, waiting for warmth to return. Imagine civilizations timing their existence to orbits, awakening in the light, sleeping through the freeze.
Every year, they would watch the sky burn and freeze, a calendar written in extremes.
On this world, survival isn't about comfort. It's about enduring the dance of gravity and light.
Because even in chaos, the universe paints beauty. Those black auroras are its signature.
So when you look at the night sky, remember, somewhere, a world burns.
Even in the harshest places, light and life all.
Imagine a time when every star in the universe has gone dark. It sounds like the end of everything, doesn't it? But even in that eternal night, black holes, the destroyers of worlds, become the universe's last beacons of light.
As matter spiral inward, it heats to millions of degrees, releasing powerful radiation before vanishing forever.
Even after the stars die, planets near black holes could still receive warmth and light.
That light isn't born from life, but from destruction. And yet,
some scientists believe that, in the far future, advanced civilizations might migrate here.
They could harvest energy from the black hole's spin, tapping the last source of power in a dying cosmos.
It's called the Penrose process, a way to draw energy from gravity itself.
These would be the last lighthouse of intelligence, shining long after the galaxies fade.
But even black holes don't last forever. They slowly evaporate through something called Hawking radiation.
It's a process so slow it would take more than 1 trillion years to complete. And when the last black hole fades, the universe will fall silent, a darkness without end. But before that happens, for unimaginable ages, these black holes will shine on. The last witnesses of existence, the final storytellers of the cosmos.
They remind us that even in the end, there can still be light.
When all the stars fade, the black holes will remain.
Because the universe doesn't just end, it transforms, leaving behind beauty, even in silence.
Yet, even in that endless night, something still burns. The black holes. If a civilization survived that far into the future, they wouldn't draw power from stars.
Black holes don't just destroy, they spin, and that rotation holds unimaginable energy. Imagine harnessing that power, extracting energy from the black hole's very spin. That's the Penrose process, an idea born from physics, where gravity itself becomes a generator. A civilization could build enormous structures around black holes, harvesting energy for eternity. Picture an entire city powered by the spill of a black hole, the last beacon of life in a dying cosmos. These dark worlds would orbit where the last light of the universe still burns.
The sky would never see sunrise, yet it would never be completely dark.
The black hole would become their sun, feeding cities, warming oceans, sustaining life in the void.
Scientists call it the ultimate energy source, far beyond fusion or fission, pure gravitational power.
Perhaps such civilizations already exist, thriving silently in the universe's fading light.
They may be the last witnesses of existence, guardians of knowledge in a universe gone quiet.
And when the final black holes fade, even they will vanish. In the twilight of time, the last spark of civilization might come not from the stars.
The final light of the cosmos will be born from the heart of darkness itself.
Have you ever wondered if a black hole, the ultimate destroyer, could one day simply disappear? It sounds impossible, but even the darkest objects in the universe slowly fade away. For decades, African-American female scientists believed black holes only consumed, never released.
Then Stephen Hawking proposed something revolutionary. Black holes emit light.
It's called Hawking radiation, tiny bursts of energy born from the quantum fabric of space itself.
Near the black hole's surface, pairs of virtual particles constantly appear and vanish. But if one particle falls in while the other escapes, the black hole loses a bit of its energy.
And so, slowly, imperceptibly, the black hole evaporates. It's like a candle burning in the dark, its flame faint.
A black hole as massive as our sun would take 10 years to fully evaporate.
When the last stars are gone, these black holes will still shine, quietly, patiently. The irony is breathtaking. The universe's greatest symbol of death becomes its final source of light.
As a black hole shrinks, its temperature rises. It gets hotter, not colder. And in its final instant, it explodes in one last burst of radiation, a cosmic farewell.
A brief, beautiful death.
Everything in the cosmos has a beginning and an end, but energy never truly dies.
It only changes form. Light becomes shadow, shadow becomes light again. Even destruction can feed creation. It's the eternal rhythm of the universe. When we look into a black hole, we're not just seeing death, but the final whisper of energy returning home.
Imagine standing on a planet orbiting a black hole, its sky carved open by a glowing ring of twisted light.
The black hole doesn't shine, it bends reality, pulling light into a halo that circles endlessly. You look up, and it feels like you're staring into a hole in existence itself.
But if you listen closely, not with your ears, but with understanding, you might hear it.
A heartbeat, slow, deep, and ancient. The universe.
Scientists call it gravitational waves, ripples in space itself, born when black holes collide or spin.
In 2015, detectors on Earth heard one for the first time. A whisper from two black holes.
That signal traveled over 1 billion years to reach us, a faint tremor of the universe's heartbeat. Here, near the black hole, time slows, space stretches. Every moment feels like eternity.
You can almost feel it.
The universe is never truly silent. Even here, it hums softly in the language of gravity. Look closer, and you'll see that destruction and creation share the same heartbeat. Every black hole is both an ending and a beginning, a bridge between what was and what will be.
Perhaps somewhere, or something, can still hear that cosmic pulse.
Because even in silence, the universe breathes. It never stops moving, never stops becoming. And if you ever find yourself staring into the darkness, remember, it's alive.
You're not just looking at the end of everything. You're listening to the heartbeat of eternity.
Imagine a universe where every star has faded, every galaxy gone, and only darkness remains.
In that endless night, a single light still burns. A black hole.
It sounds impossible, doesn't it? That the universe's destroyer could also be its last source of light.
Every black hole was once a star, a massive sun that lived, burned, and finally collapsed.
Its death was not an ending, but a transformation, a doorway into something new.
The universe is full of such paradoxes, destruction that creates.
Think of it like the changing of seasons. Winter may kill the forest,
but spring grows from its ashes.
The same happens in the stars. Their deaths seed the cosmos with elements of life: carbon, oxygen, iron.
In a way, we are made of the ashes of dead stars, children of explosions and light.
One day, when the universe grows old, black holes will outlive everything else.
They will emit a faint radiation, Hawking radiation, until even they fade away.
But perhaps, within that fading light, lies the spark of something new. It's poetic, isn't it? The end of everything giving birth to the beginning of something else. Maybe the universe doesn't die at all. It just changes its form, its rhythm, its purpose. Black holes remind us that even in darkness, energy finds a way to live on.
The universe, after all, is not about endings. It's about transformation.
When all the lights go out, perhaps life will be found in the heart of that darkness. Because black holes, like everything else in the cosmos, carry the promise of rebirth. In the end, it may be the darkness itself that teaches us what light truly means.